Okay, now what does this mean? Okay, let's say that P of X is, I'm going to use my purple shirt example again. Okay, so we're going to say that P of X is that X is wearing a purple shirt. And we're going to say that Q of X is that X has a giant Q on his shirt. His or her shirt. And our universe of discourse is going to be people. And we'll just say that it's people in this room, just to make it something we can talk about. Now, what does not for all x P of X mean in English? The way to figure it out is to write for all x P of X in English and then negate it. Okay? So for all x P of X means that everyone in this room is wearing a purple shirt. So we're just going to do for all x P of X, everyone is wearing, I'm just going to leave everyone, I'm going to leave the in the room off, a purple shirt. And then if I want to negate that, the first thing I would do is say not everyone is wearing a purple shirt. Right? That's one way to write it. So you can write not everyone. We just don't usually talk like that because it's a little hard to figure out what you mean if you say not everyone. But you all know people who do that. You know, they make a joke like, not everyone thinks that money will buy everything, right? So people might say something like that, but we also want to figure out how to say it in another way so we don't have a not and an every in the same sentence, because it's kind of confusing, right? So how many people have to not be wearing purple shirts to make this false?
Just one.
Just one. So I could say there's at least one person that isn't wearing a purple shirt. That would be the same as not for all x P of X, right? That's the same as saying not everyone is wearing a purple shirt. So this is writing the English directly from that. So not everyone is wearing a purple shirt is just writing the English from not for all x P of X. Then if I wanted to make it a little bit more understandable English sentence, I would say there's at least one person who's not wearing a purple shirt. Or I could say there is someone who is not wearing a purple shirt. Just got a little journey there. So how do I write that in predicate calculus if I want to convert it back? I now have a there is instead of a for all, right? So that's a there exists statement. So there's a person who is not wearing a purple shirt. How do I say X is not wearing a purple shirt?
Not P of X.
Not the quantity P of X. So I put not P of X. And these two things are logically equivalent. So we've just figured out for ourselves what DeMorgans is for quantifiers. These symbols, the for all and the there exists, they're called quantifiers. And they're called that because they're telling us when or how often the X is going to make our statement true. So it quantifies the statement. So let's write this on another sheet and just talk about it a little bit more. So we've just shown that for all x, if I negate for all x P of X, that's logically equivalent to saying there exists X so that P of X is false. So this is DeMorgans again. So DeMorgans is basically all the rules that let us apply knots and move them around. Anything that does that is called DeMorgans. He did lots of work with logic. Okay, so if you had to guess, what would you think would be logically equivalent to negating a there exists?
All.
A for all, and then what?
Not P.
not P of X, and that's true, actually. So if I said it is not true that there is someone wearing a purple shirt, then that means that everyone must be wearing something besides purple. Right? So if I want to figure out how to write there exists X P of X, not, I write there exists X P of X. There is someone wearing a purple shirt. If I wanted to write a not for that, I would say there is no one wearing a purple shirt. And then if I wanted to change that to talk about what everyone is doing,
Everyone is not wearing a purple shirt.
then what I know is true about everyone is that everyone has something besides purple on. So that would be for all x, P of x is false. Everyone is wearing a non-purple shirt.
Everyone is not wearing.
I'm sorry, I'm making up my own words. Right? Or I would say, it's true that everyone is not wearing purple. It's a little bit confusing, right? So usually in English, we just switch between and use the one that's the least confusing for talking, or at least we try to do that. But we might, sometimes these might be, we might need one or the other, and we need to be able to convert back and forth in logic. So now let me ask you a question. The question is, does it matter where the not goes? Is this statement and this statement, are they the same? Not the same at all. It's just like the difference between where the not goes with ands and ors, right? So ands and ors are not the same at all. Just because this has a for all x in it and a not doesn't mean it's the same. The order really matters. Because this is logically equivalent to there exists, right?
Yeah.
This is there exists x, not P of x. And then it's really easy to see that these are different. So DeMorgans, if you remember, when we did DeMorgans, whenever we applied DeMorgans when we had P and Q, and then if we negated that, then we negated the variables and switched the and into an or. I can remember the same rule with DeMorgans here. If I apply a not to the for all, I switch it to the other quantifier, and then negate everything on the inside. Yes?
When you're using this notation, can you use the bars?
I don't normally use the bars, but you can.
Okay.
So you can combine the notations if you like. The only notation I don't like for nots is the quotes, because quotes look like random scratches on your paper. And you might miss them, or I might miss them, or you might put lots of random scratches on there if you don't know the answer. So I would much rather use any other notation besides the quotes. I don't think any of you would do that on your homework, but other people have in the past.
But it is easier to use the quotes in the computer than these other
It is
two.
easier in the computer, and that's fine because there shouldn't be any random marks on your nice, clean computer paper. So it's fine. If you're doing your work on the computer, the quotes are fine. Okay, so now that we've learned this rule, let's get a little bit of practice using it. Actually, let's talk about combined quantifiers. We're not going to talk about what this means yet. So after the for all x, after that all the x's go with the for all x, and after the there exists y, all the y's go with the there exists. So in this case, suppose I want to do DeMorgans on this statement. Okay, if I want to do DeMorgans, what would I do? I would change the for all into there exists and then negate the contents, right? So I would get there exists x, not the rest of the stuff. So I'm going to do this one step at a time because then I won't make any mistakes. So then if I apply DeMorgans again, I get there exists x, and this not applied to the there exists gets a for all y, and then I negate the contents, which is p of x and q of y. And then I can use DeMorgans again, which is our regular propositional DeMorgans rule. And I leave the quantifiers the same. I get not p of x. The and changes into an or, and I get not q of y. So there's an example of doing multiple steps of DeMorgans on a line, so I can negate the entire line.